Hi everyone. In today's video, I'll be showing you how to conduct a chi-square independence test. So this is a test that takes place when looking at the possible dependence of two variables. The variables could be of any nature, but in particular here I've chosen two variables that are qualitative. On the one hand, there is the hair color of a sample of individuals that has been collected, and as well as the region where these individuals live. So you can probably tell from the contingency table that I currently have that 31 individuals who reside in the prairies have hair that have been ascertained as being either dark brown or black, and so on. So these would be what we call the observed frequencies, the number of individuals that have been observed through sampling and land in a certain category or into an intersection of two categories. So the first thing that we'll have to do is to create the expected frequencies, which may very well differ from the observed frequencies themselves. So right now I've simply recopied the table, so obviously there's no difference between the two tables, but the first one, keep in mind, is those that have been collected from sampling, and in the second I'll erase the content of the table so that I can recalculate the entries in terms of what the expected frequencies would be. So when we say expected frequencies, we mean how should these individuals have been distributed if hair color and the region where the individuals live were completely independent. So we're not going to change the total number of individuals, neither in the rows nor in the columns, but we're going to redistribute them in a way that would highlight perfect independence of the two variables. You may recall in class that to calculate the expected frequencies, you would multiply the row total with the column total at a given position. So for example, if I'm in row 1, column 1, so prairies and dark brown or black hair, I would be multiplying the total number of individuals in the first row with the total number of individuals in the first column, and then I'd be dividing by with the grand total. Okay, so row total times column total divided by total number of individuals. Now that's all fine, and you can certainly go through all of the cells this way, but you'll agree with me that this will be a little bit tedious. So I'll show you a quicker way of doing this without having to insert dollar symbols. So some of you may be very comfortable with dollar symbols, and that's great. I'm going to show you an alternative here. Now, one of the shortcuts is to actually give names to different regions of your file. So here's what I'm going to do. I'm going to take these totals that are on the right, so all of the numbers that are the sums of the row totals, and I will go to the top left of the screen where it says name box, and I'm going to call this row total. Of course, you can choose a better name that's smaller or that's shorter, but you know, for the sake of clarity, I'm going to write row total here. So from now on, whenever I type row total, Excel will understand that I'm referring to these entries. At the bottom are the numbers that are obtained by adding up the entries of a column. These will be my column total. And here, why not? At the bottom right is the actual grand total. There you go. Notice that if you do go back and reselect the entries at the right, you will see row total. I have to be careful here because I put an S to my column total and not to my row total, but still, as long as we're consequential, it'll be fine. Okay, so I've given names to the row, column, and grand totals. And in my new tables, my expected frequencies, I will simply tell Excel to do the row total, multiply it with the column totals, and divide by the grand total. You see, sometimes Excel will even suggest what you want to enter. Grand total. And look at that. Excel just assumed that you wanted to repeat this process for all of the other cells. If it doesn't, so if you have a version of Excel where this step hasn't been done for you, then you can simply copy and copy and drag or click and drag your formulas to repeat them everywhere. Now notice that the row totals have not changed, the column totals have not changed, and obviously the grand total has not changed either. But what has changed is how many individuals are found in each of the locations or in each of the cells. We used to have 31 individuals, and we are down to, well, okay, not much of a change, but to 30.98. But there are other cells where bigger differences occur. There are only 4 individuals in that bottom right position. Now there are 8. Following up on that, we'll go ahead and create another table that calculates the chi-squared coefficient itself. Chi-squared is actually quite a lengthy process. It is obtained by comparing the expected frequencies, and notice I'm going to do this for every pair of cell. So I'm going to choose the expected frequency, compare it or subtract from it the observed frequency. So at a corresponding position, I'm looking at the difference between what was observed in reality and what is expected in the case of independence. I will square that difference, which is what a chi-squared process is meant to do, and we always divide by the expected frequency. So for that first cell, we've done the difference between the expected and the observed frequency. We're squaring. We don't want positive and negative differences to cancel off, hence the process of squaring. So we're sure that we're adding positive differences, and we are dividing by the expected frequency. Okay, so a very small number in this case. Now this process can be repeated to all of the other cells. Very quickly, you can simply place your cursor on the bottom right corner of the cell where you entered the formula, and if you pull to the right, it will repeat the operation that you did to the neighboring cells. We have to go down 5 more columns as well. There we go. So these are all the individual chi-square values for pairs of cells. Now the chi-square itself is calculated based on the sum of these differences. So we're going to add all of these differences or these disparities between what was observed and what was expected in terms of frequencies. All right, so in this case, 25 is actually the value of the chi-squared obtained from this sample. What does that mean in terms of p-value, or what does it mean in terms of the hypothesis test? I'll show you while we're at it. So if you recall, most probability functions or most probability distributions have functions in Excel that resemble their names. Now, in French, chi-squared starts with a K, but in English, chi is written with a CH. So if you type CH, you'll see the list of options that are there. So char doesn't sound about right, but chi-squared distribution certainly does. So chi-squared distribution is the option we would like to choose. Even better, chi-squared distribution right tail is most likely the function that you'll be most interested in, because this function will calculate the probability of obtaining a result that is equal to or further from 0 than 25.69 is. Again, these are topics seen in class. So for now, I'll show you the technical aspect in Excel. So I'll select chi-square distribution, right tail. X is the value that you have calculated for the chi-squared, so 26 in this case. And then I need a separator, which is a comma in this case, and I need to specify the degrees of freedom. For chi-square independence tests, the degrees of freedom are calculated by multiplying the number of rows minus 1 with the number of columns minus 1. So our table had 5 rows and 4 columns, so we're not going to do 5 times 4, but rather 4 times 3. So 12 degrees of freedom. And the output that we get is a probability. As we'll see in class, this probability might be an indication that there is or that there isn't any differences between the distribution of hair color among the different regions. So maybe we'll conclude with this number that there is dependence or maybe independence. Those are things that we will have to renegotiate. So I hope you didn't get your hair all bundled up after this, and I will say goodbye until next time.